This video goes over the use of the multiple series effect size calculator, specifically focused on calculating non-overlap of all pairs, standardized mean difference, and log response ratio effect size estimates. When using the multiple series calculator, the first section that I encounter is the data section, which lets me select what data to use for effect size calculations. You're able to use an example data set, which you can select from this dropdown, or upload your own data. Using an example dataset can be helpful for exploring how the app works and considering best practices for organizing your data to use in this calculator. To upload your own dataset, you will need to make sure that it is saved as a .csv, .txt, or .xlsx file, and select the appropriate upload button. Here, I'm using data from a 2013 study by Laura Bassett and Teresa Tabor Dowdy that implemented a dog reading visitation program where students read self-selected books aloud to therapy dogs. This study evaluated the effects of the program on the academic engagement of students with emotional and behavioral disabilities. The primary dependent variable was percentage of time on task while reading aloud. The file I'm uploading is a .xlsx file, so I will click here and upload my dataset. If there is more than one sheet in the file, you can select the sheet with your data using this dropdown. Okay, now that the dataset is loaded, it automatically populates our data screen so that I can check that it was read in correctly. After I've uploaded my dataset, a dropdown menu will appear asking for filtering variables. This is useful if you've got a big data set that includes some rows you don't actually want to use for effect size calculations. I'll leave this blank. Let's take a look at the data set and how it is organized. First, I have the column participant, which differentiates between students 1, 2, and 3. Then I have phase, which has baseline phase coded with an A and treatment phase coded with a B. Session enumerates the time point or session during which each score was collected, and score provides the percentage of on-task behavior reading aloud. Now that I've uploaded my dataset, we can move on to the variables section of the page. This section gives the calculator the information it needs to understand what each column in the dataset represents. The first section here needs my series identifier. This would be a column indicating the case name for each student. If I'm using a data set that includes more than one study, I would also include the study identifier here. For my data set, I can input the variable participant. Then I want to consider aggregating identifiers. These are columns that identify variables to average across after calculating effect size estimates. For example, if your data comes from an AB design for each of several participants, you might want to summarize the effect size comparing B1 versus A1 and the effect size comparing B2 versus A2. I want to get an effect size index for each participant in the study, so I'll just leave this blank for now. The next three sections are to identify the column with phase indicators, as well as the notation used to indicate baseline versus treatment phases. For the phase indicator section, I can now select the name of the column. For me, this is phase. Then the baseline phase value and treatment phase value will allow me to select which unique entry of this column indicates baseline and which indicates treatment. In my case, I select A for baseline and B for treatment. I can then move ahead to within case session number, which is a column that sequentially orders each case, representing the session during which each outcome score was recorded. Here, I use the column session. Next, I input the column containing the outcome data for the sessions. In my case, it is the column score. Lastly, I select the direction of improvement for our study, whether the study is designed to increase or decrease the behavior that is measured. If you have data where the direction of improvement varies between series, you can select by series and indicate a column that specifies this. All of my data corresponds to intended increases in on-task behavior, so I am selecting all increase. Now that I have completed all sections on the variables tab, I select the plot tab in the panel on the left of my screen. The plot tab displays a graph of outcome scores by session number, differentiating by color the phases in the data. Here, I can use the display plots for each value of this variable selection to specify variables for the plot to be grouped by. Selecting participant here lets me see graphs for each of my participants. If I go back to none for that selection, I can also use the selection box, select a value for each grouping variable to plot certain values for the grouping variables. For example, I can just look at one of my participants at a time. Now I'm ready to move on to the estimate section to select the effect size indices I'm interested in calculating. I'll start by just calculating non-overlap of all pairs so that we can see the simplest scenario for using the multiple series calculator. Once I've checked the NAP box, there are a few additional options to look at. Confidence level specifies my preferred coverage level for the confidence intervals for effect sizes that have known sampling variances. The default is 95%, which I will keep as is for right now, but you can adjust to your needs. The digits option gives the number of digits reported for effect size estimates and confidence intervals. The default is 2, which I will keep as is for right now, but you can adjust to your needs. Here, we also have to select between a long and wide format for the output of our effect sizes. When estimating a single effect size, the selection here does not matter. I will discuss this option later when I demonstrate how to calculate more than one effect size. Now that I'm done here, I will click Estimate and view my example results. The results are displayed in a table that includes the effect size estimate, standard error, and confidence interval. You can also press the Download Results button to download the results as a .csv file. One of the handy features of the multiple series calculator is that I can calculate more than one effect size measure for the same set of data. I'll now go back and add in 2 more effect sizes, the within case SMD and the log response ratio for increasing outcomes. I now have more specifications I can make. Since I'm calculating SMD, I'm asked what to standardize by. This determines whether the effect size will be calculated using the standard deviation of the baseline observations or using the standard deviation pooled across the baseline and treatment phases. I will select baseline, but you should select what is most useful to you. Since I'm calculating LRRI, I'm given the option to convert to percentage change. I will select this option to give me an additional output that can aid in interpreting my results. I can now consider outcome scale, which tells the calculator how the outcome measurements are scaled. This could be a percentage, proportion, rate, count, or other. In my case, all of the outcome scores are percentages of on-task behavior, so I can select all percentage. Intervals per observation session lets me select a variable in the dataset that contains the number of intervals per observation session if relevant. This entry can also be left as NA if the series was not observed using an interval method. I am leaving this as is. I can now select a column corresponding to the observation session length in minutes. If this value is unknown, you can select NA. Then, the user-specified floor constant provides the option to specify my own truncation constant instead of the constant calculated based on information in previous fields. I will leave this blank. Lastly, I can select from a long or wide format, which will determine the way that the output is displayed. Long format has each effect size estimate appearing in a separate row. Wide format has each effect size appearing in a separate column with a single line per data series. I'll keep the default long format. Now that I'm done here, I can click Estimate to view the example output. From here, I'm able to look at results as well as press the Download Results button to download them. The location where the downloaded file will appear depends on your computer and browser settings. But here, I can see the file appear where my downloads are located, and I can open the file onto my computer from there. Here, I have estimates for NAP, LRRI, and SMD for each individual student, as well as corresponding standard errors, confidence intervals, and baseline standard deviations where relevant. For example, taking a look at student 2, I have a NAP effect size estimate of 0.97, which tells me that there's a 97% probability that a randomly selected observation from the treatment phase improves upon a randomly selected observation from the baseline phase. I also have a standard error estimate of 0.04, which gives me a 95% confidence interval of 0.67 to 1. The LRRI effect size estimate of 0.23 represents the natural log of average percentage of on-task behavior in the treatment phase divided by that of the baseline phase, giving me a relationship in terms of proportionate change. I also have a standard error of 0.09, giving a 95% confidence interval of 0.06 to 0.4. I also have this converted to a percentage. It is estimated that there is a 26% change in on-task behavior from phase A to phase B with a 95% confidence interval of 6% to 49%. I also have an outcome for SMD where the estimate of 1.1 indicates that the average percentage of on-task behavior shifted by 1.1 standard deviations between the treatment phase and baseline phase. This estimated effect size has a standard error of 0.48 with a confidence interval of 0.16 to 2.05. Note that the app also reports the baseline standard deviation. Since the outcome measure is percentage of on-task behavior, the baseline SD indicates that the standard deviation of the data during the baseline phase was a little more than 13.42 percentage points, which is consistent with what I saw in the graph on the previous tab. Clicking on the Syntax for R tab provides auto-generated R code that I can then copy and paste into R for replication purposes. Once I click copy, I can go into RStudio and paste the auto-generated code into an R script. I edit the path to indicate that my file is located on my desktop and then evaluate the full script. This provides the same results located in the res dataset in my environment. I can take a look at those results by clicking on res here. In this video, I've demonstrated how to use the multiple series effect size calculator to compute non-overlap of all pairs, standardized mean difference, and log response ratio effect size estimates. Of course, there are other effect sizes that you can calculate using this app, and it's up to you to decide which effect size estimates are most useful for your work.